Hey everybody, Mrs. Bianchi. We're looking at a question that some people don't really fully understand, so let's try to break it down. Which expression is modeled by the diagram below? So what are we starting out with here? We're starting out with 3 1/4. So whatever we're starting out with, and they show that here, I'll just shade it on the number line. We have 3 1/4. That matches up with the length of this rectangle. Now, are we asking ourselves how many groups of 3/4 are in 3 1/4? And are they showing us how many groups there are? So if we count, that's 1 group, 2 groups, 3 groups, 4 groups, and not really quite 5 groups, right? Because if we had 5 groups, it would be this. And we didn't quite make it to the 5 groups. So the question is, how much of this last red box do we have? And do you see how we have 3 chunks that size that are in that last red box? Are you seeing that? So if there's 3 chunks, how many chunks are shaded in blue, in this darker blue? Isn't it just the 1? So let's count how many complete boxes we have. We have 1, 2, 3, 4 complete boxes, which they show you here. See, 1, 2, 3, 4 complete boxes. So let's write that number down. And then how much of this 5th box do we have? We have 1, 2, 3 boxes, but only 1 out of the 3 is shaded. So it looks like the model is showing us 4 1/3 as an answer. So if we go through each one of these and try to decide, if we actually do the algorithm, which one is going to give us 4 1/3? So let's look at choice A. If we were going to do the algorithm, step 1 would be to turn any mixed or whole numbers into improper fractions. So that would be something fourths divided by 3/4. To get the something, recall that we have to multiply this times this, which would be 12, and then add in the 1, which would be 13. Then we would apply keep, change, flip. We would keep the 13 over 4, multiply by the reciprocal of the divisor. So the reciprocal of this, if we just flip this around, we put the 4 on the top, and the 3 would go on the bottom. All right, we have a nice reducing opportunity right here. 4 goes into that once, 4 goes into that once. These do not share any common factors, so we're ready to go across. 13 times 1 is 13. 1 times 3 is 3. So we need to find if 13 divided by 3 will match our model. So wouldn't that go in 4 times? And we would get the 12. And if we subtract, we get 1 left over, so 4 1/3. Does that match what we had up here? It does. So it looks like we're going to be picking that one. Now remember, the dividend is always the thing that you're starting out with. The divisor is how you're breaking it up. And then the answer is, how much is in each group. So A is a contender. Now if we were actually going to do the algorithm for choice B, let's make sure that that one's wrong. So if we do the algorithm for that, let me copy this and move it over here, and we'll actually do the algorithm. So if we do the algorithm for that, it's 3/4, and then it would be times the reciprocal. So now first of all, we'd have to turn that into an improper fraction. We already know that's equal to 13/4, so the reciprocal of that would be 4/13. Now in this case, we would be dividing here, and we'd be dividing here, and we'd be getting 3/13. Now, is that what this model shows? 3/13, that's a value less than 1. That's not represented in this model. So B is not a choice. That's not one we're going to pick. This model doesn't represent that at all. Now, if we look at choice C, and let me move these boxes out of the way, and let's look at this thing again. We'll clean it up. Choice C says 3 broken up into equal groups of 1/4. Now, I don't see the value. Let me move this out of the way so we can see what's under here. The value 3, this isn't a 3, it's 3 1/4. It's not 3. So we're not breaking up 3 into equal groups of 1/4. And are we taking groups of 1/4 and breaking it up into 3 groups? Nope, we're not doing that here. So in review, A is the correct answer.